Once again, good morning. So now, is my screen is visible? Okay. So this is our third unit, which we learned. Which we are started in the last week. We learn only basic concepts, introduction to regularization. Today in a revision recap, I will redefine what is regression. What is regularization? Why we are using this regularization? So regularization is a mechanism which is used to reduce generalization error. Or simply regularization is used uh, which controls the model. To understand this controlling of the model, that simply we can say it is optimization, optimizing the model. Control the model and optimization of the model. To understand this regularization concept, we should have an idea what is meant by regularization. What is meant by overfitting and underfitting constraints. So overall, regularization is performs controlling the overfitting, underfitting problems. For that, we are using regularization mechanism. How we are applying this regularization, now we'll see. In this unit, we are going to cover all these topics that I already explained in the last class. So anyway, maximum topics will cover today. Comes into the introduction of the regularization. So what is the situation when we are preferring to use regularization? Say, for example, we have constructed a model that is implemented, that is designed using linear regression. So we have data points like this. We have data points like this. Several data points are there. So by using a regularization, by using a model construction, a linear regression, using linear regression, we are constructing a model. Say, for example, this is the plane, hyperplane, which we are using to divide these data points as class A data points and class B data points in the classification task. So using linear regression, we are classifying the data points like this. So suppose when we are classifying data points, instead of classifying like this, so we can also classify like this. We can also classify like this. We can also classify like this. So these lines we are calling simply line or a plane or hyperplane. That depends on the model. Whatever we are doing here, it is classification. We are classifying our data points into two classes, class A, class B. This overfitting and underfitting problem is arise. How accurately we are classifying the model, data points. So how we are best line is created. That is main thing. This best line, we can say it is a best fit. So when the data is having like this linear, we can apply simple linear regression like this. We can classify these data points are comes under class A and remaining these data points are comes under class B. This is very simple. But when we consider data points in different, it is flatted like this. It is flatted like this. So here we are going to construct a linear regression. It classifies like this. or it classifies like this, or it classifies like this. Okay, so anyway, same concept I'm saying. Linear regression is classifies with the line, straight line. So how we are going to say this is best classifier? So based on the classification of the data points, maximum data point should be classified properly. What is the maximum data points classified properly? That means to understand this, you just consider these data points in different way. Instead of this, I am going to redraw. I'm not good in drawing in this online mode. Okay, see. So we have data points like triangle data points, and also square data points, triangle data points, square data points. Like this, we have different data points. Okay. When we are classifying using linear regression, this is again triangle. This is, you can consider triangle. So when we use a classifier like this, or when we classify like this, so how we are going to say this is a best classifier, this line is best classifier? Because so based on the classification, so maximum triangles are classified in class A, only one triangle, 1, 2, 3 outside, but comes into the squares, only one square is having inside this class A. So this is you can consider A class, which is belongs to triangle, B class, which is belongs to square. So you just see here, this line, separable line, is best fit for this model because only one element from class B is placed here in class A. Only one element. But comes into this class B, class A elements, two class A elements are misclassified. So this line classification is good because it is having minimum error. Only two data points and one data point. This is having minimum error. Okay. So like this, when we are constructing a model, classification model, you have to classify with minimum error. This is having minimum error. Are you getting my point? So when we are creating a model, classification model or some other model, for understanding, I'm consider here classification task. In this classification, I'm going to classify my data points, triangular data points into class A and square data points into class B using simple linear regression, a line, it is a straight line. Okay, so it classifies maximum accuracy. That means which is having minimum error. Only one data point from class B is classified in class A. Two data points are classified in class B. So it is having minimum error. There is no harm using this classification. Suppose when we are classifying this one like this line and this line, sometimes we can consider like this, straight line, one more line. Now tell me which is the best classifier. Which line is best classifier of all these data points? So which is the best classifier? Which hyperplane line is the best classifier? This line is best classifier because it is having only accuracy is high, minimum error. Misclassifications are minimum. When you consider this line, only one triangular data point from class A is classified in class B. Maximum 1, 2, 3, 4, 1, 2, 3, 4, 5. 5 squares are misclassified. That means error is high. So this is not right classifying line, best fit line. This is not best fit line. This is best fit line as of now. So when you compare this one, this is also not best fit line. So when we are constructing a model, we need to classify with minimum error, less misclassifications in this classification example. That is our goal. So how we are doing all these things means by using a regularization, we are going to control these misclassifications. Okay, with this linear simple example, can I easily identify. But when we consider data points which are having like this, so now we have to classify like this curve. Okay, so when we are classifying like this, maximum, this is, okay, this is line. So only one square, one delta is misclassified. So this is a not a straight line, this is curve. So simply we can say it is a quadratic polynomial curve, quadratic form or polynomial curve. So this polynomial curve which generates a classification accurately. Similarly, when we are using nth degree polynomial, so sometimes a line is used, sometimes a curve is used, sometimes a different shape of curve, degree more than 3. Okay, so like this we are using different classifications to classify our data elements. So whenever it is having more generalization error, then it occurs overfitting problem. When we have more generalization error, more text error, then automatically it comes under underfitting. To control these things, control these misclassifications, okay, control this overfitting problem, underfitting problem. So we are using optimization techniques, best fit techniques that can be done with the support of regularization. This is basic definition of the regularization. This is we learned in the last class. So how we are implementing this regularization? Now we know that why we are using regularization. Then how we are going to reduce these errors. So how the errors will be happen and how we are going to reduce these errors. So by using some regularization strategies, we are going to reduce these errors. That means we are regularizing the model, controls the model. So this regularization helps to predict output with new input. Unknown inputs also, it controls the model with the regularization. So what are the strategies we are using? So overall thing is we are reducing the errors. That error is a generalization error. This strategy, we can call it as, we can apply some constraints. Okay, see this, the simple definition. If we are doing any modification, we make a learning algorithm model that is intended to reduce the generalization error. So if we are doing any modification after generating the output, so what is the meaning of after generating the output? We are giving input, the model is applied, machine learning model or deep learning model is applied, and we are generating the output. This output is having misclassifications, more misclassification, that is error, more error. Then we are going to modify this. Then we are going to modify this learning algorithm that reducing the generalization error. So when we are modifying the algorithm, that is trying to reduce the error. For reducing the error, we are trying to modify. So what are the mechanism? What are the strategies we are using to control the model? That is called regularization control strategies. So regularization control strategies in machine learning. So I told you all these topics are started with machine learning. So generally in machine learning, we are using these regularization strategies. What type of strategies we are using? So common and simple strategies are these two. These two strategies are very famous while controlling the model. These two are using. One is restrictions, another one is preferences. So what is the restrictions? So restrictions are nothing but we are imposing some restrictions on the parameters. We are imposing restrictions on the parameter. So again, what is parameter and how we are doing restrictions on parameter? Simple example, when we consider a linear regression, y is equals to beta naught plus beta 1 x. Simple from this 10th standard, y is equals to mx plus c. Here, parameters are c is a constant, is a parameter, m is a slope variable, this is also a parameter. These two are the parameters. Okay, so we are applying these restrictions on the parameters. So why we are applying restrictions? Applying a restriction is a strategy. So by applying these restrictions, we are controlling this output. So some textbooks, they are mentioned beta naught, beta 1. Some textbooks, they are mentioned theta naught plus theta 1 and so on. So when we are using simple linear regression, which is having beta naught plus beta 1 with binary classification. With binary classification, we are going to add one more binary value, beta 2 x2. Okay, so based on the linear regression, polynomial regression, that is quadratic polynomial, or degree 4, degree 5 polynomials. So based on these polynomials, the parameters will be added. So our target is we need to control these parameters. Okay, we need to modify these parameters to control the model. For this modification purpose, we are applying strategies, regularization strategies. So one of the strategies is restrictions. That means we are imposing some restrictions on theta. That means we are modifying a theta value by using some restrictions. And also the preferences. Another way of controlling the model is using preferences. So what is the preference here? The preference is, okay, the preference is nothing but we are selecting a particular feature. By giving a priority, we are selecting particular parameter. Parameter value is updated instead of updating all parameters. We will select a particular preference. So based on that preference, we are modifying. So that modification will reduce the error. So this is the way we are doing regularization concept, strategies. So these strategies, restrictions, also called as constraints. Another one is a preference. This regularization of an estimator works by trading increased bias for reduced variance. So what is the intensity is? So you just remember this is a question from the mid exam. So mid exam lo kuda idi question ichcham. Bias variance trade-off అని చెప్పేసి. So what is this bias variance trade-off? When we consider the model overfitting, underfitting model, the bias value, this is bias value. So what is bias here? Bias is nothing but it is having some constraints. So based on the constraint conditions, we are generated the model. And the variance point of view, this is a variance line. Oh, sorry. Variance is low to high. This is variance. When we are identifying capacity value, this is capacity. Okay, this is variance and this is bias. Here it is variance. Here it is bias. And this line is a variance. This is variance. This is underfitting. This is overfitting. This is capacity value. So when we are using this capacity value, so based on this capacity, we identify the model accuracy. But when we are considering bias value and variance value, so when bias is high, variance is low, then this model comes under underfitting. That means model is too simple. Okay, it is having more errors. When we are having a high variance, low bias, this is forms the overfitting. The model is complex model, and it is having error. Error is high. Misclassification is high here. Misclassification is high here. These cases. So to control these, we need to find this capacity. This is best fit. For doing this best fit, we are implementing some restrictions. This regularization is an estimator works by trading increased bias. So we are increasing the bias. So when we are increasing the bias, obviously this is come down and reaches to the this one. Reducing the variance. When we are reducing the variance, automatically variance will be reduced. So reducing the variance on overfitting. When overfitting is arised, we are trying to reduce the variance. When underfitting is arised, we are trying to reduce bias. Okay. So by reducing the bias when the model is underfit, by reducing the variance when the model is overfit, we are achieving our goal, that is optimal capacity. So this is the main intensity which we are using regularization. So not on generalization error and train error. The same you can consider like this is training error and this is test generalization error, test error. This is train error. So train error and test error. Test error is high, train error is low, then also it is overfitted. But we are not reducing these things. We are not reducing the training error and testing error. Using regularization, we are doing the reductions and increasing of the parameters. That should be in terms of bias and variance, not in terms of training and testing errors. ఈ ఒక్క పాయింట్ మీకు క్లియర్గా అర్థం చేసుకుంటే రెగ్యులరైజేషన్ ఎలా అప్లై చేస్తున్నాము, అదర్ మిషన్ లెర్నింగ్ అల్గారిథమ్స్ ఎలా ఉన్నాయి కూడా క్లియర్గా అర్థమవుతుంది. సో వాట్ ఈస్ అవర్ ఇంటెన్సిటీ యూజింగ్ రెగ్యులరైజేషన్? Regularization is an estimator. That means it is estimates works by a trading increased bias on reduce the variance. Bias and variance trade-off is estimated using regularization, not generalization and training error. Okay. For that we are using so many constraints implemented. So constraints we are using here. These constraints, one of the constraint is penalization. Okay, so we are applying penalties on the parameter. Okay, so that mechanism we are calling as a parameter norm penalization. Okay, that means we have a parameters theta naught, theta 1, like theta is a parameter. So this theta is nothing but theta 1, theta 2 vector, which is having n number of parameters. So based on the model, we are having only 1 theta, 2 thetas, 3 thetas. That means 1 parameter, 2 parameter, and other parameters. Now you are connecting my point. Theta is a parameter. So based on the linear polynomial or some other nth degree, so theta value will be imposed. So our target is we need to control this value. That means we need to apply constraint or a condition on this theta. So what type of constraint we are applying? This is nothing but a penalty. We are applying penalty on the parameter, norm parameter. This is not a normal parameter. So we are going to consider norm penalty. Okay. So norm penalty we are applying. Using this, we can control our model. For that, we are using penalties, parameter norm penalties. Now see, what is this parameter norm penalty? So using linear regression and logistic regressions, we can control the model. So as I mentioned earlier, so when we are having a misclassification with the straight line, data points are in curve manner, then we can use a logistic regression, either using a linear regression or non-linear regression. Misclassifications we are trying to reduce. This is possible This is simple mechanism. So this is one of the regularization mechanism. Simple regularization mechanism is this. This is, but this is not sufficient in all the cases, because this is used to reduce the training error and testing error. Training error and testing error reduce cheyadaniki ee mechanisms use chestam, linear regression and non that is logistic regression. But our intensity is using a regularization. Bias and variance trade-off you need to consider. So you have to use penalties on the parameters. So many regularization algorithms are based on limits the capacity. So you know that we are going to limit, optimize, control the capacity value of the model, overfitting and underfitting model. So most of the regularization algorithms are working on this, controls the capacity value. Now we can see, we can denote this J. J is a regularization function. Okay, so J is a regularization function. Our target is we need to control J value. Okay, how we are defining J here? Using norm penalty. So J of theta, that means our target is we have to predict J value with the parameter, because we are going to use parameter norm penalties over the input value X, and we are identifying output value Y. So this is capital X, which is having vector X1, X2, X3 and so on, Xn. This is why we are predicting single output. Okay, so we are generating the output X with X inputs, respect to X inputs, with the control of parameter. This is theta. So that is represented using J of theta X comma Y plus alpha into norm theta. So what is this alpha into norm theta? This is, we are adding norm penalty. Okay, parameter norm penalty. So this is a parameter using norm penalty omega with the constraint we are adding. So just we are adding this one, this is to this output. So then our model will be optimized. That means it limits the capacity by adding the parameter. Okay, this we can say it is a norm penalty. You just remember this equation. This is very, very important. This is very, very important equation. So using this, we are going to apply norm penalty. How we are limits this one is with the support of norm theta is nothing but adding a norm parameter. So where alpha value is start with 0 to infinity, it is not a negative, non-negative value. So we can say it is a hyperparameter that weights are relative and contribution. The weight will be considered relative contribution. So why we are going to consider weights? So whenever error is happened, we are updating the weight values. Weight value updation should be done. So using weight value updation, we are generating the reducing the error. So hyperparameter is weight value. So we'll see different norms we are penalizing in different layers. So every layer it is having weight values. When we are having or when we are adjusting the constraint parameter layer by layer, every layer weight value is going to be controlled. For that, we are using L2 parameter regularization, Lagrange's parameter, L2 parameter. Okay, so this is also your mid-exam question. What is L2 norm, L2 regularization? Okay, L2 parameter regularization. So that is norm 2. This is the equation. Okay, so this is from the first unit. ఇక్కడ చెప్పినది కాదండి, ఇది మనకు first unit, second unit లో వచ్చింది. So using the L2, that means L power 2, L2. Okay, so we can say this is like L2 norm regularization. Okay, L2 regularization. Using L2 regularization, norm value is 1/2 weight 2 and 2, because it is a L2. If it is L1, it is a simple W norm. W norm is a simple. Okay. Hello. So this is the main regularization L2 regularization, we are applying cost penalty. You just remember this one also. This is we are using here. And then this is the name ridge regularization. So we are applying ridge regularization. So there exist several regularizations. We are applying simple ridge regularization. So this ridge regularization is applied on theta. So you just theta is just like a W. Theta value is 0. That means there is no weight updation. I mean, there is no parameter updation is performed in terms of weight. Okay, so why means we have L2 parameter, L2 regularization parameter, which is working on weight updation. Weight updation to chestunam kabatti in terms of weight. Okay, so weight updation is done to reduce the error. Every layer we are updating weight value. So you need to consider ridge regression. What is the ridge regression here? It is considered like a theta is just W. Okay, so this is a previous equation. What I told you, remember this equation, right? So this equation is, this is a normal equation. Now by applying this ridge regression, what is the ridge regression? Theta is just like a W. So you have to replace this theta value with W, x comma y equal to J into W x comma y plus alpha omega W. Because we are applying ridge regression, theta is nothing but a W weight value. So we are replacing theta with W value. So so that we know that we have a L2 regularization parameter in terms of W weight updation. So W is also a parameter. Okay, W is also a parameter. Weight parameter, we can say it is a weight parameter. Sometimes we are calling input parameter, weight parameter, output, like this. So weight parameter, this parameter is going to be added. So now we are going to you can consider this as equation number 2. Okay, this is equation number 2. By replacing ridge regression theta value, we got this, and you just replace this omega theta equal to half into W2. So this value you just replace with this one. Okay, so initially what we did, so we are applied weight value. So this is equation after converting, and then we can apply this norm weight value in place of this. So replace this W value. So then you will get this one alpha by 2 W transpose into W1. So then you can use the parameter, corresponding parameter gradient. That gradient is nothing but downsizing the weight value, reducing the weight value using delta. Okay. So with respect to W, you just add this one in front of this. So because we are down reducing the weight value W. Okay. Here also you can use delta. Okay, so why we are adding this delta W? Delta W we are adding because we are reducing the weight value from maximum error to minimum error. When we are reducing the weight value, when we are having high error, to reduce this high error, to reduce this variance, okay, to reduce this variance, we are updating the weight value. What is the updation? Weight value updation. Weight value is high, so we are going to come down this weight value, reduce this weight value. Reduction is done using delta W. Okay, so which is maximize the regularization object. That means which is having maximum control. So using gradient descent algorithm, so we are going to reduce this. Okay, so weight updation is done using single gradient. So it is nothing but just we are modifying this. Okay, so this is a gradient parameter epsilon. So using this gradient, just we are adding gradient. So how we are adding gradient? Actual weight value is W. We are reducing using minus. So what is the reduction? Reduction of weight value is gradient value epsilon with our added penalty. That means penalized weight value. You need to copy this one. Okay, so this is like this. So you try to understand the complicate. It is very difficult to understand. So like this, we are reducing weight value. After reducing the weight value, so we are storing this value into the again weight variable. So this is the one way we are reducing the error. That means control using regularization. One of the constraint is parameter penalization. Okay. So using parameter penalization, I'm repeating this again. Using parameter penalization, we are going to reduce our error controlling the model. That means controlling the capacity of the model by adding parameter norm. So what is a parameter norm? Norm theta, we are adding alpha into norm theta. So theta is a parameter. Our concentration is on theta. We are generating output. So this output is generated based on input x comma y. So x is a vector which is having x1, x2, x3 and so on. Vector values. This is the theta. So parameter. Okay. This is the output. Okay. This is the output. With adding the penalty, we are controlling the model. So this is the output. If it is more accurate, which having less error, that is okay. If it is having more error, then we are going to adjust. We are going to modify this error, reducing the error by adding the norm penalty. Okay, parameter norm penalty. Adding the parameter norm penalty is one of the regularization constraint strategy. Okay, how we are applying this? So to apply this, you just remember regularization, L2 regularization. We are adding L2 regularization to this thetas. With this parameter theta, it is not possible. So we need to apply ridge regression. So in place of theta, replace with weight value. So our target is reducing the weight value. So after changing this weight value W, you just apply L2 regularization. Then you need to reduce weight value from actual weight value. Actual weight value minus calculated weight value. Reduce, that means error weight value. So you need to reduce this. So that weight value is updated. This is the main and basic technique we are using in penalty normalization. That is norm penalization. Okay, after using this, we are generating a weight value, weight updated W star. Updated values always represent with the star. Okay, you just remember star indicating updated value. Updated weight value is a minimum weight value of JW. Minimum weight value of JW. What is J here? J is a parameter norm penalization. Okay, so but in terms of norm penalization, we identified minimum value. So minimum weight value. So weight value is minimum so that our error is minimum. Misclassification is less. So this is actual model predicted. So this is a more accurate output, but the weight value is high. So by using norm penalty, adding norm penalization, we are reducing this distance from target to the generated one. After reducing the distance, this is the updated weight value, which is having very close to target. Okay, so like this, we are applying penalties. That is one of the constraint. So for that, we are using penalty normalization. This is another strategy. Norm penalties as constrained optimization. First optimization is by adding penalty, parameter norm penalization. Second one is norm penalties as constrained optimization. Constrained optimization here using the condition. The condition is optimized using norm penalties. So you need to calculate norm penalty as it is. ఇందాక చేసినట్లు norm penalty as it is calculate చేయాలి. చేసిన తర్వాత you need to optimize that. Again, you need to optimize that value in terms of condition, constraint. Okay. So this is the way we are doing. So obviously you have to consider all the calculation. This is norm penalty calculation. Indak chesam kadandi, equation gurtupettukondi ani cheppanu kada adi. So from this you have to apply constrained optimization, where k is a constrained optimization parameter. So using this, what we are doing is, earlier we have applied minimum, augmin. Now we are adding maximum. After identifying the minimum error, then we are from the what we call L2 optimization, we are going to consider maximum value, which is having in terms of alpha. So where alpha value is nothing but a constraint. Alpha value is a constraint. So this is reducing the, updating the parameter. This is updating the parameter. So wherever having stop, you can remember this is updation. Parameter is updated. That means norm penalty is updated. So with this theta, you can replace weight value as it is. Then you will get the norm penalties as a constrained optimization. This is one of the strategy we are using in regularization. So this is the way we are applying minimum. First we have to do with respect to theta, minimum value you need to identify. So augmin, which is nothing but, so L theta alpha star, which is nothing but j theta of x comma y. What is j theta of x comma y? This is j theta of x comma y. You can replace this. What is the value of this? So this is, you need to replace. So what is the value of this? This value is calculated earlier, weight reduction. That is one of the mechanisms. So another regularization mechanism is under constrained problem. So this is constrained optimization. Another one is under constrained optimization. So under constrained optimization is nothing but, so we are going to implement using matrix. Okay. So some of in some cases regularization is necessary for machine learning models. You know that why it is regularization is necessary. Optimization is necessary. Controlling the model is necessary. So many linear models, machine learning models, which include linear regression and PCA, okay, principal component analysis. I will explain later. It is there in our syllabus. So using these, the matrix is applied, transpose of x, that is input value is transported and multiplied with input values. That is also one of the way to reduce. But this is not possible whenever x transpose x is a singular value. If it is a singular value, it is not possible. If it is not a singular value, you can apply all these things. The matrix is a singular whenever the data is distribution is no variance in some directions. So what is the meaning of here? There is no variance. So this is a variance. There is no variance means this model is not having control. So variance and bias, variance is no variance. If it is a singular, there is no variance. So model is not accurate. So for doing this, you need to use under constrained optimization. So you have to add this alpha into I, identity matrix, and alpha is a constraint. That is a condition. Okay, parameter. By multiplying this alpha value with identity matrix along with the singular matrix, then it is generates variance. So based on the variance level, we can identify, we can regularize our model. This concept is called as under constraint problem. So under constraint problem is also one of the strategy to implement regularization. So these three strategies we are using: penalty normalization, that is parameter norm penalization, and norm penalty constraint based. Another one is under constraint. Three methods we are using to regularize the model. This is simple one. Okay. In the afternoon 12 o'clock class, I will going to discuss about remaining topics, data augmentation. Majority of the unit I am going to cover afternoon. From this point, it is easy to understand. Okay. So there is no mathematical calculations from this point, the remaining unit. Okay. So you can easily understand. That will cover in 12 o'clock. So do you have any queries? Only two members are there. If you have any query, raise your queries. Otherwise, post queries, personal WhatsApp, I will clarify your queries.